Hello and welcome to Mechanical Y. Here I have a drill bit. This drill bit has two cutting channels known as flutes and is made up of carbon steel. Here I have another cutting bit. This particular bit is known as an end mill. It has four flutes that cut as it spins, and it cuts both from the side and its tip. This particular end mill is made up of a material called high-speed steel. The yellow gold color comes from a titanium nitride coating meant to reduce friction and wear on the bit, thus giving it longer life. So what is the difference between these two apart from the manner in which they cut? The key difference is in the type of steel that they use. In order to understand that difference, we have to understand what steel is made up of. In general, steel is primarily made up of iron and carbon, but it can also include other alloying elements to improve properties. When making some tools, steels with relatively higher carbon content were preferred, especially in cutting bits like this drill bit, because of its natural wear resistance and ability to hold an edge. But these steels lose their hardness at high temperatures, meaning that they have to be run at relatively slower speeds to reduce the amount of friction, thus reducing the amount of heat the bit experiences. High-speed steel, as the name suggests, can operate at higher speeds because it can handle higher temperatures. This is because of the relatively lower carbon content of the steel. However, this comes at a price, as the lower carbon content means the steel is slightly more prone to wear, meaning that coatings like this titanium nitride are much more important. But wait, many of you may be asking, what about diamonds? You've heard that diamonds are the hardest material on Earth, as some cutting bits are coated with a diamond edge to retain sharpness. Others may have heard about carbide tools. There are many types of carbide, but titanium carbide is often used in tool manufacture. Titanium carbide is very tough and hard and makes an excellent cutting edge. And it can be found in tools like this circular saw blade, where the teeth are tipped with carbide. Diamond and carbide are quite resistant and durable, and they make excellent cutters. However, with seemingly superior materials like this, why would anyone still use steel? The primary reason is the chemistry of the materials. Diamond is made up of carbon atoms, and titanium carbide, as the name suggests, contains a high amount of carbon, much higher than the high-speed steel or traditional carbon steel. And that carbon can be the limiting factor. As I mentioned earlier, steel is made up of iron and carbon, and the amount of carbon determines the steel's properties. I also mentioned that these can reach high temperatures. Chemical reactions are accelerated at high temperatures, and if you mix the wrong materials, undesirable reactions can occur. So let's say that I'm using a cutting bit like this circular saw made of carbide tipped teeth, and let's say that I'm cutting a workpiece made of iron like a pipe. This cutter will get hot, the iron pipe will get hot, and then chemistry happens. Carbon from this carbide cutting tip will leach into the iron wherever it comes in contact with it. The surface of the cut is going to have a higher carbon content than the rest of the material, effectively hardening it and making it more brittle. Furthermore, the cutting bit is going to lose some of its carbon and thus lose some of its desirable properties. These types of reactions can happen with some materials but not others. Carbon steel and high-speed steel do not have a high enough carbon content for this to be a real concern. So, if I'm cutting slowly, carbon steel is an excellent and effective choice that is also very affordable. But if I'm cutting materials like iron and steel quickly, I should be using a high-speed steel bit, preferably with a wear-resistant coating. But if I'm cutting non-ferrous materials like aluminum at high speed, I want to use a carbide tip like this circular saw. It is important to research the material being cut to determine which cutting bit is best and what materials should be mixed with others. Otherwise, you can damage your workpiece and damage the tools by fundamentally changing their chemistry. And that could be dangerous in the long term. Well, thank you for watching. I hope you found this interesting. If you did, please like and share this video, and please subscribe to stay up to date on new content. Also, please visit us at our website, www.mechanical-y.com.